Hello everyone, in this video we're going to be solving a geometry puzzle. Two circles are inscribed in a 25 by 18 rectangle as shown. Find the length of the orange segment that is tangent to both circles. Alright, at this point you can just go ahead and pause the video and give this problem a try first. Alrighty, so what are we supposed to do here? We have two circles and we know that the side length for this rectangle is 25 by 18. So this is going to be 18 and this whole thing here is going to be 25. Cool. So let's go ahead and make some connections here as usual. I'm going to go ahead and drop a perpendicular from here. So it's going to go like this. And then I'll drop another perpendicular here. And then I'll be connecting the centers, of course, right? We always do that. Let's go ahead and connect the centers, which is always a good idea, right? Okay. And then we can just go ahead and draw a parallel line here to take advantage of the Pythagorean theorem. It's basically we're getting a trapezoid and we'll just use that. Okay, so since the height of this rectangle is 18, I can safely say that the radius of the larger circle is going to be 9. And if you call this one the smaller radius r, then I'm going to get r here and 9 minus r here. This is going to be 9 and this is going to be r. And I'll be getting a right triangle here whose hypotenuse is 9 plus r. And the height would be 9 minus r. So the base, which we can actually write in terms of r, goes as follows. This part is going to be 9 because we get a square here in the corner and this part is r. So if you go ahead and add those and subtract from 25, this piece actually is found to be 16 minus r. Okay, awesome. And that's going to be the base of my right triangle here. Okay, so let's go ahead and write the Pythagorean theorem and let's see where that takes us. And then we're going to be using the information for r because we're supposed to find the length of the segment here between these 2 points. And for that one, we kind of need to find where they are located. Okay, or what the lengths are. So let's go ahead and set up our equations here. So our equation is going to look like this. It's going to say something like 16 minus r squared plus 9 minus r squared equals 9 plus r squared. As you know, we always have an identity here. If you subtract this expression from that expression, that's going to give us 16 minus r quantity squared is equal to 4 times 9 times r, which is 36r. That kind of simplifies the process. Let's go ahead and expand it. And I can actually go ahead and write the r squared first to make it a better quadratic. So it's going to look like r squared minus 32r plus 256 equals 36r. And if I just go ahead and put 36r on the left hand side, then I'll be getting r squared minus 68r plus 256 is equal to 0. Okay, now how do you solve this problem? You can use the quadratic equation, but you can also consider factoring since this one is factorable. Okay, so what are the factors? We got to find two numbers whose product is 256 and whose sum is negative 68. And those numbers are negative 64 and negative 4. Awesome. So then I can write this expression as r minus 64 multiplied by r minus 4 equals 0. And from here we get the two solutions, r equals 64 or r equals 4. Obviously, this circle is inscribed in a 25 by 18 rectangle, so there's no way the radius can be this large. So we're going to discard 64 and use r equals 4 for our figure. So r equals 4, right? So we know that now. And using that length, we can actually calculate more lengths here, but we also have to consider a couple things here. So let me go ahead and write this down here. So r equals 4. All right. So r equals 4. So what I'm going to do now is I'm going to go ahead and clean this up. And we're going to use that information that r equals 4 and find the length of the segment. All right, let's go ahead and clean this up a little bit, except for the fact that r equals 4. So this should be good. Now, what do we know? Well, we know that r equals 4, so we had called this length. If I redraw some of these lengths here, so I can just go ahead and drop a perpendicular like this, and then like this one. Okay, so one of the things that you should pay attention to here is this one. The point of tangency, this segment here and this segment here are equal lengths, right? Because we're drawing two tangents from a point to a circle, and these two segments will also have the same length, which means that these two are actually congruent. But we know that this is 4 and this is 9. So what we have left is 9 plus 4 is 13. Subtracted from 25, you get 12. So each of these pieces must be 6. So that's nice because that gives us the lengths that we are looking for. Awesome. So what is that supposed to mean? Well, we now know that where this point is located on the base of the rectangle. And then we're going to use that information actually to find the length of this segment. But we do need the coordinates of these points first. And what do I mean by coordinates? What I mean is we're going to put this on a coordinate system. So it's going to look like this. All right. So suppose this is the origin. Okay. And we're going to use analytical geometry here. So what are the coordinates going to be? Well, I do know that. First of all, let me make this connection again so I can actually calculate what I needed, because I'm going to need that connection one more time. Okay, so here's the fact. Obviously, the radius is perpendicular to the tangent, right, at the point of tangency. So that's a 90-degree angle, and that helps us because I'm trying to find the slope of this orange segment. But if I go ahead and calculate the slope of this segment here, right, then I can actually use that fact because these two segments are perpendicular, so their slopes are negative reciprocals. So how do we find the slope of this segment here? All right, that I marked the endpoints with. Okay, well, I'm just going to use the coordinates of the points. Obviously, we do know that this is going to be 9, and this is going to be 9 as well. All right, so to find the slope of that line, I'm actually going to make a right triangle here, so I can show you what our picture looks like. And slope is going to come from the fact that it's rise over run, right? Okay. So tangent alpha here basically is going to give us the slope. What is tangent alpha? Well, here's the thing. We know that this whole thing is 9 and this is 4, so this must be 5. This here. And then this piece is going to be 6 plus 6, which is 12. So this is 12. So tangent alpha is 5 over 12. Okay, so M1, let's call that the first slope. And I'm going to write it as tangent alpha, and that is equal to 5 over 12. M2, which is the slope of the orange segment, is going to be the negative reciprocal, which is negative 12 over 5. Okay, so by using analytical geometry, we found the slope of this line, and we actually know a point on the line, correct? And we can also find the coordinates of this point. How? Well, once we find the equation of the line, we can just go ahead and calculate this because this is going to be our x-axis, right? Since this is the origin, that would be my x-axis. So let's go ahead and calculate this here. Let me go ahead and clear this area up so that I can use it, okay, for my calculations. Let's go ahead and clean this all up. Now what we're going to do here is write the equation of the line using a point. Now, what are the coordinates of this point, right? Well, this point is given as 15, 18. Let me go ahead and write that down here. So this point has the coordinates 15, 18. Why? Because this is 9 plus 6, so the x-coordinate is 15. And since it's up here, and the height of the rectangle is 18, the coordinates of this point here, let me make it bigger, is going to be 15, 18. Awesome. And I know the slope of this line, so I can calculate, I can write the equation. And the formula we use for that one is y minus y1 is equal to m times x minus x1. I'm going to use the point slope form. Let's go ahead and write it down. Okay, here we go. Now what I have is the y coordinate of that point, which is 18. The slope is negative 12 over 5, as you know, that's m2. And the x coordinate of this point here is going to be 15. All right, awesome. So this is my equation for the orange segment. I want to know where this intersects the x-axis. So what I need to do is then replace y with 0. So let's go ahead and do that. If you replace y with 0, then you'll get the x-intercept of this line, which is this point right here. So let's go ahead and do that. Negative 18 is equal to negative 12 over 5x plus, if you go ahead and cross cancel, you're going to be getting a positive 36. Is that right? 5 goes into 15 3 times, and that should be a 36. If I go ahead and isolate x here, negative 12 over 5x is equal to negative 18 minus 36, which is negative 54. And then from here, actually, I can find the x value. All right? Okay. So what am I supposed to do from here? Let's go ahead and calculate x. So x is going to be equal to 5 times 54 divided by 12. That's going to be a positive. But 12 and 54 are both divisible by 2. So that's going to be 5 times 27 divided by, and we can actually divide both by 6. So that would look like this. Okay, let me go ahead and write it down first, and then I'll simplify in the next step. So it's going to look like this. And then divide by 6, this is going to be a 9, right? And divide by 6, this is going to be a 2. So it's going to be 45 over 2. So the x-coordinate here is basically what I'm talking about, is this one. The x-coordinate of this point is going to be 45 halves. Now, how does that help you? Well, now I know the 2 points on the line, so I can find the distance between 2 points. I can use the distance formula to calculate the length of the orange segment. That's what I'm going to do next. So one of the points on this line is going to be 0, actually, never mind, 45 over 2 comma 0. That's the x-intercept. And the other point on the line is 15 comma 18. You know that point because we just calculated it, right, a little while ago. So these are the 2 points on my line. I'm going to find the distance by using the distance formula. Okay, let's go ahead and do that right here. So let me go ahead and calculate. So the distance or the length of the segment is going to equal the distance between 2 points, which is given by the square root of. So what I need to do here is subtract the x-coordinates, right? And obviously 45 halves is greater, so it doesn't really matter which way you subtract, but let's go ahead and do it this way. So I'm going to subtract, fine, we can do it this way. So start with the second one because that's going to be positive anyways. And then that's going to be 18 minus 0 squared. So we're basically using Pythagorean theorem to find the length of the orange segment. Okay, let's go ahead and do the math here. 30 minus 45, negative 15. Square that, you're going to get 225 over 4. And if you square this, you're going to get 18 squared, which is 324. And all of that will be square rooted. Okay, now how can we make our lives easier? Well, we're going to just need to simplify this first. So let's make a common denominator. That's going to be that divided by 4, right? So what I need to do here is I need to multiply 4 times 324, add the 225, and then we're just going to take it from there. Okay, what is 4 times 324, right? That's going to be 1,296. Okay, 4 times 324 is going to be 1,296, correct? Okay, and then I need to add 225 to it. Let me go ahead and add those. That's going to give me a 1. That's going to give me a 2. And that should give me a 5. And that should give me a 1 here. Okay, awesome. So we're basically going to be getting 1,521 from here divided by 4. And what's really interesting is that this number is odd, so we can't really divide by 4. What we need to do is square root it. But here's one fact that will be helpful to find the square root of this number. Is it an integer, right? First of all. Well, if it's an integer, it needs to be near 1600, right? Because 1600 is 40 squared, and that number is pretty close. So could it be 30 something squared? Well, I suspect 39 is a good candidate, but think about this. What is 40 squared minus 39 squared? That is going to be 40 plus 39 times 40 minus 39, which is 40 plus 39. And that's going to be 79, right? If you use difference of two squares. So what happens if I just go ahead and subtract this number? So what is 1600 minus 79? That's equal to that number. Awesome. That means that this number is actually 39 squared. So the length of the segment is going to be 39 halves then. Okay? That's the length we've been looking for, and we're done. Thank you for watching. Please comment, like, and subscribe, and see you in the next video. Until then, take care. Bye-bye.